In this example, we're going to look at adding improper fractions and mixed numbers. So we're going to use the diagrams to represent this visually, and then we're going to use the algorithm. Okay. So notice we have 7/4 plus 5/4. So good news, they have common denominators, because usually that's the hardest part. This is 7 copies of 1/4 plus 5 copies of 1/4. So even though these are improper fractions, this isn't any different from adding the proper fractions we've seen in the past. If we have 7 of something plus 5 of something, it's going to be 12 of that something, which is 1/4. So let's see what it looks like on the number line. This is broken into fourths. So this is 1, 2, 3, 4, 5, 6, 7 fourths. Notice it's equivalent to 1 3/4. We don't need that, but it's good to know. Now we'd add on another 5/4 from this point, which is 5 of these 1/4 tick marks. So 1, 2, 3, 4, 5. Shouldn't write that there. This was 5/4 from here to here. And our total is 3. Okay. So let's see how we'd see this symbolically. 7/4 plus 5/4. We add the numerators, we keep the denominator, and we have 12/4. Okay? So here you should always simplify the fraction you can. If you can. You can think of this fraction as 12 divided by 4. Then you can see the answer is 3. We also found in the diagram that it's 3. You could also use factoring. 12 is 4 times 3. They have a common factor 4, which will cancel to 1. Then we have 1 times 3 over 1, which is just 3. Okay, so if you're comfortable with it, you can go straight from here to here, but I just wanted you to see this process in case you needed it. Now let's look at an example with mixed numbers. Okay, so mixed numbers have whole number parts and fractional parts. And just a comment, when you say 4 and 2/3, notice you say 4 and 2/3. And this really means 4 plus 2/3. Okay, so the 4 and the 2/3 are written next to each other. Sometimes people think of that, or in a lot of cases in math, they reasonably think of that as multiplication. But this is really just shorthand for writing 4 plus 2/3. Same thing with 3 plus 1/2. So we could think of this, one option, which I'm not going to do, is you could change these to improper fractions and then just use the same process we used in the last video. You'll need to find a common denominator, but that's not always necessary, and sometimes it can be a little bit more work. So I'm going to show you this way. So we have 4, as long as it's mathematically correct, you can do any way you want. 4 and 2/3 is 4 plus 2/3. 3 and 1/2 is 3 plus 1/2. Okay. Now, because of the commutative property of addition, we can add these in any way we want. Okay, so this is going to equal, I'm just going to add the whole parts. 4 plus 3 is 7. That was easy enough. Plus 2/3 plus 1/2. Okay, so this really boils down to finding 2/3 plus 1/2. Okay, we did a similar problem to this before. Okay, if here are the fractional parts, we want to add 2/3 plus 1/2. Okay, 2/3 would be 2 of these. One half would be 1 of these 1/2s. Their denominators don't share any common factors besides 1, so we could just think of splitting it. Split the thirds into 2 pieces, split the halves into 3 pieces to get a common denominator. So 2/3 is equivalent to 1, 2, 3, 4/6, which is 4 copies of 1/6. And 1/2 is 1, 2, 3 copies of 1/6 or 3/6. Okay, so now we're ready to combine the fractional parts. Okay, so combined we have a total of, well, it was 4/6 plus 3/6, so we have 4 plus 3 or 7 copies of 1/6 or the fraction 7/6. That's the fractional part. We added the whole numbers already. The whole numbers were 3 plus 4, which equals 7. So now we have from before 4 2/3 plus 3 1/2 is the 4 plus 3, which is 7, plus 7/6. Okay. We need to write this as a mixed number. We would never leave an improper fraction with a whole number. Okay, so 7/6, well, 7/6 is 1 more than 1. Okay, 6 goes into 7 once with a remainder of 1. So this is 7 plus 1 1/6. We can add the whole numbers here, and we get 8 1/6. Okay. So now let's look at the symbolic representation. So we're not going to look at the pieces and the diagram, how you might just write this from step 1. Okay. So again, you could write these as improper fractions, but instead we are just going to shift the pieces. Okay. 4 2/3 is 4 plus 2/3. I just want the fractions on the right so we can deal with them on the side. 3/2 is plus 3 plus 1/2. Okay. Now we'll combine the whole numbers. Now we rewrite the fractional parts with a common denominator. Excuse me. So 2/3, we want to write that as something over 6. So multiply by 2. 1/2 as something over 6. We need to multiply by 3. So our next step is 7 plus 4/6 plus 3/6. Okay. Now we're going to add the fractional parts because we can, because they have a common denominator. So 7 plus 4 plus 3 is 7/6. And now change this to a mixed number, 7 plus 1 1/6. And finally add the whole number parts, and we have 8 1/6. Okay, so a little bit more work to do, but it basically boils down to you can combine the whole number parts, which is easy. We all know 4 plus 3. You can add the fractional parts like we did in the other lesson, find the common denominator, combine them together, and then at the end you'll just need to combine the whole number part with the fractional part. If the fractional part is more than 1, so it's an improper fraction, you'll have to rewrite it as a mixed number to combine. Okay, let's look at another one. 2 3/5 plus 9/5. Okay, so here notice they have the same denominator, but this one's written as a mixed number. This one is written as an improper fraction. But that doesn't really matter. You have the option, you can change this to a mixed number and then add, like we did in the last video, or you can change this to an improper fraction and add. Okay, but let's just look at this process on the number line so we could see really the meaning behind it. So this is broken, the unit's broken into fifths, so 2 3/5 is 2 and 1 2 3/5. So here's 2 3/5. And now I want to add on 9/5. So I'm going to count that out. 1 2 3 4 5 6 7 8 9. So that would bring us right here. This is plus 9/5 from 2 3/5. And notice we're at 4 and 1 2/5. Okay. So how might we write this? So 2 3/5 plus 9/5. Okay. Now we can just go ahead and add the fractional parts. So remember, this is equivalent to 2 plus 3/5 plus 9/5. Okay, so 2 3/5 means 2 plus 3/5. So I'm going to choose, because it's addition and it's commutative associative, I'm going to choose to add these two together first. Well, 9 and 3 is 12, so this is 12/5. Okay, now we have to turn this into a mixed number. This is an improper fraction. So 12/5, well, 12 divided by 5 is 2, remainder 2. Okay, so this is equal to 2 plus 2 and 2/5. Okay, so 12/5 equals 2/5. And now we can just add the whole number parts. 2 plus 2 is 4, and we have 4 and 2/5, just like the diagram indicated.